The James Webb Space Telescope, JWST, is a cutting-edge, infrared-optimized space observatory launched in 2021 through a collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, as the largest and most powerful space telescope ever constructed. JWST is capable of observing some of the earliest galaxies in the universe and studying the birth of stars and planetary systems. Since its deployment, JWST has become the most advanced space observatory in operation. While the telescope was not specifically designed to examine individual planets, it recently captured the most detailed image of Pluto to date. This remarkable feat was made possible by its infrared imaging capabilities, which allow it to see through the haze of Pluto's atmosphere. NASA reports that these new images have revealed previously unknown details about the dwarf planet's surface. Pluto was first discovered on February 18, 1930, by Clyde Tombaugh at the Lowell Observatory in the United States. Prior to this, astronomer Percival Lowell had theorized the existence of a Planet X due to perceived disturbances in the orbits of Uranus and Neptune. Tombaugh's discovery was quickly recognized by the American Astronomical Society, the Royal Astronomical Society in the UK, and the International Astronomical Union, IAU, which officially named the object Pluto. Once considered the ninth planet of our solar system, Pluto was reclassified as a dwarf planet in 2006 by the IAU. This decision was based on the fact that Pluto failed to meet all three criteria required to be considered a full-fledged planet. It does not clear its orbital path of other debris, even though it orbits the Sun and maintains a nearly spherical shape due to hydrostatic equilibrium. Pluto has intrigued astronomers for decades. Our understanding of this icy world significantly expanded after NASA's New Horizons probe flew past it in 2015. More recently, NASA released stunning images of Pluto on its Instagram account, showcasing the dwarf planet in vibrant, exaggerated colors. These colors were added by the space probe to highlight variations in surface composition. The images revealed a dramatically diverse landscape, including rugged mountains resembling those on Jupiter's moon Europa, networks of valleys, and terrain marked by ancient craters. One standout feature captured in the New Horizons images is Pluto's heart, a massive glacier composed primarily of nitrogen and methane. The image, taken from a distance of 22,225 miles, 35,766 kilometers, shows the surface as being layered with ices made of water, methane, and nitrogen. Scientists believe Pluto may also contain a rocky core, and possibly a subsurface ocean. The surface is a mixture of white, tan, and reddish-brown tones, with a distinctly heart-shaped area appearing bright white at the top of the image. NASA tweeted the image, noting its depiction of the true colors of Pluto, including the glacier-spanning areas roughly the size of Texas and Oklahoma. The New Horizons spacecraft, which traveled over 3.7 billion miles to reach Pluto, offered an unprecedented close-up of the dwarf planet. Measuring just over 1,400 miles, 2,250 kilometers across, Pluto is roughly half the width of the United States, or two-thirds that of Earth's moon. The data gathered by New Horizons revealed that Pluto might have undergone a dramatic geological shift early in its history. Scientists now believe Pluto may have experienced true polar wander, a phenomenon where a planet's outer shell shifts relative to its axis. This theory is supported by a detailed analysis of surface features, especially around Sputnik Planitia, the heart-shaped region believed to be integral to this reorientation. Oliver White, a New Horizons co-investigator from the SETI Institute, stated that features we now see may have originally formed when Pluto had a different orientation. One particularly intriguing discovery from the flyby is the presence of jagged terrain believed to be made entirely of methane ice. These blade-like structures may have formed due to long-term climate changes on Pluto. Their existence provides insights into how surface features evolve in response to environmental conditions, highlighting the complexity and dynamism of icy worlds. Shama Mishra, a postdoctoral researcher at NASA's Jet Propulsion Laboratory, noted that these features might exist in other regions of Pluto as well. The New Horizons team continues to analyze data from the mission with hopes of uncovering more about Pluto and other distant bodies in the solar system. They are currently evaluating the next potential flyby target in the outer heliosphere. Meanwhile, space telescopes continue to reveal breathtaking images of planets throughout our solar system. The James Webb Space Telescope recently produced the clearest image of Neptune seen in over 30 years. This new view offers unprecedented detail of the planet and its ring system, something unseen since Voyager 2's historic flyby in 1989. Neptune, now the solar system's outermost planet since Pluto's reclassification, is situated about 30 times farther from the Sun than Earth. What makes Neptune unique is that it was the only planet discovered through mathematical prediction, rather than direct observation. JWST's new images are particularly captivating because they offer a very different view compared to earlier photos, taken in visible light by Hubble or Voyager 2. While Neptune is often shown as a deep blue ice giant due to its atmospheric methane, which absorbs red light and reflects blue, JWST uses infrared imaging to provide a new perspective. In these infrared views, Neptune appears much lighter and almost ghostly, revealing atmospheric structures and dynamics that were previously invisible. One of the most remarkable features shown in JWST's images is the presence of bright streaks and patches in Neptune's atmosphere, which are actually clouds of methane ice. These clouds reflect sunlight before it is absorbed by the surrounding gas, and are especially visible in the infrared spectrum. They form at high altitudes where temperatures are cold enough for methane to condense into ice. These bright clouds help scientists understand the dynamics and layering of Neptune's atmosphere. WST also captured clear views of Neptune's rings, which are typically difficult to observe. Although Neptune's first ring was detected in 1968, their existence was only confirmed decades later during Voyager 2's flyby. Now, JWST's high-resolution imagery has not only reaffirmed the presence of these rings, but also shown faint dust bands, offering fresh insights into the structure of this distant world. These observations are critical for deepening our understanding of the planet's atmospheric behavior, seasonal changes, and overall evolution. Together, the discoveries made by the James Webb Space Telescope and the New Horizons mission are transforming our view of the outer solar system, providing unprecedented detail about remote icy worlds like Pluto and Neptune. As data analysis continues and new targets are selected, both missions promise to unveil even more about the mysterious corners of our cosmic neighborhood.